Matter. Chemistry is sometimes defined as the study of matter and its changes. But what is matter? It is anything that has mass and takes up space. Anything made of atoms. So, for example, gases are made of atoms. They take up space and, even though they are very light and you can't see them, they do have mass. Gases are matter. Energy, on the other hand, is not matter. Although energy can be converted into mass, and vice versa, recall Einstein's equation E equals mc squared, energy equals mass times the speed of light squared, it is not made of atoms, and so it is not matter. Not that it doesn't matter, it just isn't matter. I'm sure you are all familiar with the states of matter: solid, liquid, and gas. At higher energies, matter reaches a fourth state, plasma, where the electrons are stripped from the nuclei, giving positive ions in a sea of electrons. We won't be using plasma in this course. The energies are too high for anything we do. All matter can be classified by their particle types as either pure substances or mixtures. Pure substances, further classified as either elements or compounds, are matter which is made up of all one type of particle, and which cannot be separated into simpler components without a chemical reaction. Elements cannot be broken down at all. Their particles are all the same type of atom. Compounds require a chemical change to separate them. Their particles are molecules, atoms chemically bonded together in specific combinations. After a chemical change which breaks the molecules, the substance is something entirely different. Mixtures are combinations of pure substances, different types of particles, which can be separated by physical means, no chemical reactions necessary. And after separation, the individual parts retain their characteristics. Mixtures can vary in composition. For example, sweet tea can vary depending on how much sugar is in the mixture. Homogeneous mixtures are the same throughout. For example, salt water has the salt evenly distributed through the water. But if you boil off the water, a physical change, not a chemical one, you can retrieve the pure salt and the pure water separately. A heterogeneous mixture is not uniform throughout. Examples might be a mixture of gravel and sand as found on a beach, or a bowl of mixed nuts. Elements are defined as matter made up of all one kind of atom. They cannot be broken down into simpler substances by either physical or chemical means. While there are almost 120 different known elements, only about 40 make up over 99% of known substances. All the others are very rare, or artificially made in large particle accelerators. Each element has unique properties which can be classified as physical or chemical. Physical properties are those characteristics inherent in the substance itself, like color or density. Copper metal, for example, is shiny and reddish, and it is malleable and ductile. It can be pounded into sheets or drawn into wire. Sulfur, on the other hand, is yellow and brittle. It can be ground into a powder. Chemical properties are the way substances react with other substances. Copper reacts with acetic acid to form blue copper acetate. Sulfur combines with iron to form pyrite, also known as fool's gold because of its shiny gold color. Compounds are made up of two or more elements chemically bonded together. Compounds also have characteristic physical and chemical properties. Cellulose, the major component of wood, which is really a mixture, not a pure substance, is fibrous. When those fibers are packed tightly, they give wood its characteristic strength and rigidity. Cellulose reacts with oxygen at high temperatures to produce carbon dioxide and water while giving off energy as heat and light. One major component of iron ore, which also tends to be a mixture rather than a single pure compound, is iron oxide, which is reddish-brown and brittle. It reacts with carbon at high temperatures to produce pure iron and carbon monoxide in the smelting process. Each element has its own symbol, either one or two letters. Most symbols connect easily to the name of the element, but there are a few exceptions. The symbols in this list are based on the Latin name of the element. One element, tungsten in English, has a symbol W derived from its German name, Wolfram. Compounds are symbolized by a combination of the element symbols that make up the compound. Most people are familiar with water as H2O. But be careful when writing the symbols. Uppercase and lowercase letters do make a difference. In summary, matter has mass and takes up space. It is made of atoms. The states of matter are solid, liquid, gas, and plasma. Elements and compounds are pure substances. Mixtures are physical combinations of pure substances that can be separated without changing the identity of the parts. Mixtures are either homogeneous or heterogeneous. A physical property of a substance can be observed or measured without chemically changing the substance. A chemical property is how a substance reacts with other substances. Chemical symbols are one or two letters for an element, and combinations of the element symbols for compounds. Be careful of upper and lowercase letters.